Hi all, and now we can start integral calculus. So before going to the details of integral calculus, first we can discuss what is in basic integration. So consider some function f of x, and f of x I am going to represent graphically with this x and f of x, and let us suppose this is the curvature of the f of x varies with x. So graphic representation of f of x is represented here. Okay, now I just want to know what would be the area under the curve between the point A to B. Okay, so this area can be easily find out by dividing this entire area into different small rectangles. Okay, so consider a line over here and the line. So each of this area separated by delta x width. Okay, and then so the area of this shaded area, the shaded region, would be approximately f of a times delta x is approximation. Okay, and what would be the area of the second shaded region? Would be f of a plus delta x times delta x plus so on. Finally, we'll get f of b times delta x. Okay, so let us choose this initial value I am putting as x0, and final b I am putting as xn. Then this can be approximated as f of xi delta x sum over I equal to 0 to n. Also, this is an approximate area under the curve. From A to B. Now, actually, if you look at this carefully, some of the area is left behind. Particularly, if you look at these regions, so this region is not counted while we are calculating the total area, because what we have found is we have found only the area of the rectangles. Okay, so this small area is left out. Now what we can do is we can improve our calculation by reducing the amount of delta x. So by decreasing the amount of by decreasing the width delta x, we can improve the value of the area under the curve. So the calculation of area under the curve can be improved by decreasing delta x. So if you take delta x very small as possible, then we'll get the exact area. Okay, so then the exact area under the curve from A to B would be limit delta x tending to 0 sum over I equal to 0 to n f of xi delta x. Now this summation is nothing but integration. So this summation is represented as integral a to b f of x dx. So this is the meaning of integration. So integration is nothing but a summation. So we can summarize that the integration between 2 points f of x dx is nothing but the area under the curve of f of x between a to b. So this area is integral a to b f of x dx. So this integration is nothing but a summation, or more correctly, it is a continuous summation. Okay. So next, we can go for the integral calculus. That is the integration of the vectors over the line, area, and volume. So it is called line integration, the area integration, as well as the volume integration. So that we'll discuss in the next session.